So yes, the AutoGIS site, which we'll find here, is updated with this year's materials. So far, you can find the general information about the course and also this week's lesson materials. Yes, so for those of you who did not take the GeoPython course this year, or those of you who want to just refresh, there are some links here to how to install Python and creating a GIS environment on your own laptop if you want to do that. So I recommend you to read that, and also even go to the GeoPython website and refresh your knowledge from there if you want to. Okay, then if there are no questions, then I think we will proceed to get into the materials for this week, which is on CSC notebooks. So I'm going to head over to CSC here and launch a new instance of the AutoGIS 2021 here. So that is the image that we will be using. Yes, and the same as in GeoPython course, there is the image with storage, which I encourage you to use. Then you're more sure that your work is being saved and don't have to start a new one. And then we also have the without any storage that you can use as well. But we will be using the AutoGIS 2021. All right, I got my Jupyter Lab booting up. So new in this this image is that you will find in the folder structure, hopefully a folder called AutoGIS. So I recommend you to use that. Here is also the same structure for exercises and for notebooks. So we'll go into the notebooks, and for lesson 1, open the geometric objects notebook. And let me just zoom in a little bit. All right. So for this lesson, we'll be focusing on how we can create and manipulate different geometries in Python. And we will be using the Shapely package. If you click the link here, you can go to the documentation, which is handy, the Shapely user manual, where you'll find the documentation for all the different objects that we are using. So that is handy to have in the backhand. Yes, so when doing geospatial analysis, there are different kinds of geometric objects that we will be handling. So points might sound intuitive, which is it is what it sounds like. It's a point, and then we have different multi-points, which is one object that consists of many different points. We have line strings, that consists of different of lines, and we have also other versions of line strings, like the linear ring here and the multi-line string. And the last one is a polygon that you might be familiar with, which also has a multi-polygon instance or version, and then a geometry collection, which can be a combination of the 3 different main components. So we will be going through those. So yeah, the main fundamental objects are points, lines, and polygons. They are what we will be using this week. And the different objects consist in basically of coordinate tuples. So we talked a little bit about tuples in the GeoPython course, but those are basically you have the tuples that can be two-dimensional, so an object that contains, for example, an x and a y value, or even three-dimensional tuples that can also consist of a z value. The point is the simplest geometric object. It consists of a tuple, while a line string consists of a sequence of points. So point A and point B, and then that creates the line between those 2 points. And it can have many points as well. And then the polygon is an object that has an area that is filled. So it consists of at least 3 coordinate tuples in order to create a closed area, or the outer ring. The polygon can also have holes in it, and we will get back to that a little bit later. And then you have the multi-version of the different geometric objects that just contains more of those. So the multi-point contains multiple points, and multi-line string, multiple lines, and so on. Yes. So we will also be going through some different attributes over the coming weeks that are useful in Shapely when doing calculations and geometric operations. But we will get back to that later on. Yes, so we can start with the simplest geometric object, which is the point. So the way we interact with that in Python and Shapely is we need to first, as you probably remember, we need to import some packages or modules, and in this instance, Shapely. So we do that by typing from Shapely.geometry, and then from the Shapely geometry module, we import the objects that we need. So we will be needing point and line string with a capital S, and then polygon as well. Yes. So we can then create our first point object, and as you will see, here is the recipe for that. So we can create our point 1, let's call it that. And then in Shapely, we will use the point constructor that we just imported. So that is point with a capital P. And if we go back to the Shapely user manual, we can scroll down to or search for point, which there are a lot of hits for. So we can scroll down to point here. The point constructor takes positional coordinate values or point tuple parameters. So in order to create our first point, we need to pass it some coordinate values or a tuple of coordinate values. Yes. So in the simplest manner, we can here within our constructor pass it the x coordinates. Let's go with 2.2, and then our y coordinates 4.2. Yeah. So if we run this cell with Shift Enter, the points are created, and then we can try to see what our point looks like. Yeah. So as you see, here we have a point. We haven't begun to create any or define any references, geographic reference system. So at this point, it's just a Cartesian reference system with our points at these coordinates that we gave it. So at the moment, they don't necessarily make that much sense, but they will later on. Yes, and as I mentioned earlier, we can even create a point with 3 tuples as given it a Z value as well. So if we want to create a 3D point, we can do that here. We also create it with the same point, and within the parentheses, we can just use this point as the same and give it a Z value as well, 0.57, for example. And if we want to see that, as of now, as we're in a 2-dimensional reference system, it doesn't show any difference between the Z values. But as we can see, there is a point that we created here. So we will get back to how those 3-dimensional or the 3rd dimension will be visualized later on as well. But now we have the points created. All right, so we have visualized our points. We can also try to see more about the information that is defined within the points. So for example, if we want to print point 1, and we can also print our 3D point to see the difference here. If we print those two, we see we have a point object and then the 2 the coordinate values for that point. So our point 1 has these 2 coordinates, and the point C, this indicates that it has a Z value and has this 3-dimensional tuple here. All right, we can also check out the type of our point. As you remember, the type function is handy to quickly see that which type our object is. And as we can see here, it is a shapely point from the geometry point module. And we can even go further and check out some of the attributes that are stored within this point. So one of the attributes that shapely point has is the geometry type. And so if we type point.geom_type, we can see that the type of the object is a point. So that is what we would expect. But we know that it also contains some coordinates, so we can also try to get those. So if we type point1.coords, use that attribute, we will probably get an error. No, we will just see this coordinate sequence that doesn't really make sense when you just look at it. But if we try to make a list out of the coordinate sequence, we can get a list of the coordinates of that point. So that is one way to access the coordinates of the point or get it as a tuple. But another way to interact or to get the coordinates is to use the XY attributes. So I'll just do that. So if we type point1.x, or let's pass this to a variable called x, and do the same with y, point.y, point1.y. Then if we were to print x and print y, we would get the x and y coordinates separately. All right, so there is a question in the chat, which is good, that asks why that Jupyter is able to directly show the point as a figure that we saw earlier as here, as a point. the question is which other platforms you could use to code Shapely, which are able to easily show figures as well. That I am not sure of how you would do that directly, but we will in the coming weeks we will be going through different ways to take the points and plot them on a map or on an image figure. So yeah, there are also the library that we used in GeoPython, matplotlib. There are also possibilities to plot coordinate pairs and tuples onto a figure as well. So, but we will get into visualization a lot later on in the course as well. But good question. All right, we can, yeah, so when we have 2 points, we can, there's also the possibility to calculate the distance between different points that we have in our system. So first we can here just check what our point, if we use our point 1 and point 2 that we created earlier, we can check the information that we have on them and see their coordinates. So at this point, we they are not in, we haven't defined the coordinate reference system. So depending on what reference system we are using, later on we will see that, then we can get the measurements in meters or in different measures. But for now, we can calculate the distance in this Cartesian coordinate system that we are using. So if we are to say we want to save the distance between the points in a variable called dist, then we can type point 1, and then we want the distance from point 1. We use the distance method, and within the parentheses, we type point 2, and that saves it to memory. So if we want to print dist, or we can even do it with an F string. So the distance between the points is, and then within curly brackets, there I have dist. And if we run that, we see that the distance between the points is 29.72 units that this measurement is. Okay, I hope that was understandable so far. I think we can, before we dive into LineStrings, I think we can take a short break. So let's meet up again at 4. So we just a quick break for 6 or 7 minutes, and then we will be back. All right. I think we can dig into LineStrings as well. There is a question on the chat about linear rings versus polygons, and it has been correctly answered in chat already, so that's very good. I'll try to, I can get back to that when we have gone through LineStrings, because that might make it a bit more clear, the difference. But we will continue with LineStrings now. And to, yes, so the LineString objects are quite similar to the Shapely points that we have been through now. So if we check back to the Shapely user manual, we can see on the LineStrings that the constructed LineString or the LineString constructor takes an ordered sequence of 2 or more x, y, and then optional z point tuples. So an ordered sequence here just means that the order in which the point tuples are given matters for when you are creating the line. Okay, so let's try to create our first line string. So in this code cell, we will create a variable called line and use the line string constructor. And as you saw, we need a list of tuples or shapely point objects. So we could here pass it, use the square brackets to indicate a list, and then give it the different points that we created earlier. So point 1, then a comma, point 2, comma, point 3. So here the order is from point 1 to point 2 to point 3. If we run that cell, the line is created, and we can also create it with passing the coordinate tuples, as you saw. So here the coordinate tuples, or we have a list, first of all. Here it starts list, and then within the list, the first element here is the tuple, indicated by the parentheses with the coordinates x and y. And these are the same that we used in the beginning when we created the 3 different points. So if we create line 2 with these coordinate tuples, we can then see if the line 1 with the list of points and the line 2 with the list of tuples are the same, which they should be, and that is true. So you can create the line string either way if you want. So now we can take a look at what our line looks like. So by running line in this cell, we can see here that it has created a line from, that looks like this, that goes from the different points that we gave it in this Cartesian coordinate system. And we can, if we try to print the line, we can also see here that we have a line string object that has these coordinate tuples, or these coordinates within it. So these, and as you see, they look a little bit different, as the line string object represented here are the first object is, or the first object before the comma is the 2 coordinates from the first point, and then the second, and so on. So it contains 3. This instance, our line contains of 3 coordinate pairs. And as with the point, we can also check the type of our line. We see that we get a shapely line string object, and we can also check use line.geom type in the same way as we did with the point to see that we have a line string. Yes. So when we are interacting with the line string, some of the attributes and functions that we can use, we'll be going through now. So first of all, we know that our line string contains different coordinate tuples. So let's try to get those in the same way that we did with our point. So line.coords. And here we also get the coordinate sequence. So as we did with the points, we turned it into a list. And then here we get the output, a list of the different tuples for each point. Another thing we can do is to try to get the x and y coordinates using the xy attribute. So in our points, the points only had one x coordinate and one y coordinate. So in that sense, we could use the point.x, but since the line has several x and several y coordinates, we can access all the different coordinates with line.xy. If we run that, we see that we get an array of first all the x coordinates, and then so we have an array here with all the x coordinates, and then one with all the y coordinates. So what we could do if we want to access just the x coordinates, we could get the first array within the array that we just got as an output. So if we only get the first instance here, we only get the x coordinates. But if we then were to make it into a list, the same way we did with the point, we could then get a list of the x coordinates in this way. So if we pass that into a variable called x coords, we can do the same thing with y coordinates. Make a list of the line.xy, and then the last, or the second array. So if we then are to print out the two the x coords and y coords, we see we have then two lists, one with the x coordinates and one with the y coordinates, which is handy later on. All right, so another thing you might want to do with a line is to calculate how long it is to get the distance of the length of the line. So if we create a variable called line L for line length, we can use the line string attribute called length to get that. And we can try to just print L length. And we see that the length of the line string is 52.46 units, as it is in this Cartesian reference system. Another thing that you might want to do with the line is to get the center point of the line, and Shapely has an attribute called centroid that does that for you. So if we print line.centroid, we get a point output. So we get a new point that is in the center of the line that we have created. So since our line has 3 points, it would be somewhere in the middle here. Okay, so that was the brief introduction to line strings. And then we can, if there are no questions about that, please just let me know if there's something you don't understand or want me to repeat, or if I'm going too fast or too slow. Type it in the chat or use some reactions. But if not, I think we can proceed with polygons. Yes, so the polygons have the same logic that points and line strings have. So if we go back to the Shapely user manual to check how we create a polygon, so here. So we can see that the polygon constructor takes two positional parameters. The first is the ordered sequence of coordinate point tuples, and is treated exactly as in the linear ring case. I didn't cover that, but I'll give you an example of how the polygon, we'll go through the polygon creation just in a minute. And then the second optional unordered sequence is something that specifies the interior boundaries or holes of the polygon. So, and you can see there are some examples here. So here we can see we have a polygon that is the square, and then we have a hole within that. So most importantly right now, the polygon here, we have to give it a shell. So the first element, that is an ordered sequence of coordinate tuples. And then we have the option to pass it a hole as well. So we will go and try and create our first polygon. Yes, so we will create a polygon called poly. So it used the same logic as points and line strings. So, but we are using the polygon constructor. Within the parentheses there, you remember we need to pass it a list of at least 3 coordinate tuples. So in order to make it a full polygon, we need, if we have just 2, then it would be a line, but connecting to a third point would create a polygon. So we pass it a list in square brackets, and then we can use if we use these points here that are the same as we have used before, just copy and paste them in there. We create the polygon. So, and if you go to the course website, there is also an example of how you can create that with using something called list comprehension that we just very briefly talked about in GeoPython, but the Shapely module has been updated. So before it was necessary to do that, and sometimes it is handy to do it, but not for our needs. So if you want, you can go to the website and check that out in the notebook there. But for now, we will just create a polygon. We'll call it poly2, and use the polygon constructor and just pass it a list of the 3 points that we have. Let's see, a list of point 1, point 2, and point 3. So now that doesn't give us any errors. So that means that the polygon was created. And so yeah, so these are 2 of the ways, and then there's the third list comprehension way that you can check out on the website. But these 2 ways, by passing either all the coordinate tuples or passing it passing it points, Shapely points that we already have. So like we did with the line string, we can now check whether or not the 2 polygons are equal to each other, so that they are the same. So poly1 double equals poly2 returns true, so they are the same. And then we can check out what our polygon looks like. So here you see it created a polygon from the 3 points that we passed. So that is successful. And we can also here print our polygon to see that it is a polygon object with the coordinate tuples from our points. Yes, so, and as you can see here, the polygon is filled here in this light green color. So for instance, if we were to create a linear ring, we can, if I create a new code cell here using the plus sign, we had our line. You can see that it had the same points. So if we had a line going from the last point to the first one, it would be a line ring, or we could create it as a line ring, but the area inside would not be filled. And in some case, we couldn't use it to calculate, for example, the size of that area. We could calculate surrounding or the outer ring, but we can use it to see what is inside the ring or inside the polygon, the area in the middle, which is much easier when we have a polygon object. All right, so let's continue with what the polygon is. We can check the type here as well. Type of poly is a polygon, shape the polygon. And also here we can still use the geom type to get the geometry type that Shape.the has, and that is a polygon. Yeah, so a handy trick to use if you don't remember what an object is and what it contains of, and don't remember the link to the user manual, you can always use the help function in Python. So when running help.polygon or help parentheses and then the object that you want to know more about, it will here it's commented out because it will provide a longer doc string, but you can then quickly get the information about what the object is and how you construct it. So that's just a handy tip there for you. But as you remember, it is also possible to pass the polygon creator or constructor a hole. So we will try to do that now. So first of all, we will create a border that has the coordinates of the outer perimeters that might look familiar to you from, see, the world coordinates. So if we create a polygon from that border, which has the, as we saw in the documentation, we can pass it shell is the first instance that we pass, or the first parameter that we pass to the polygon constructor. So if we shell and use border, we can try to print world just to see what it looks like. We see we got a polygon here with the coordinates just in the same way as we did before. So if we were to plot the polygon, we can see here we have a large square with the coordinates of each corner here. So then if we want to try to create a hole within that polygon, we can, here we have a list of coordinate tuples that are, you can see the values are just inside the values, coordinate values of the border that we created above. So if we pass that into a list and then create a polygon, let's call it frame, that using the polygon constructor has the shell, that is the border that we used before. And then we can pass it the optional parameter of holes. And here we will use the whole list of values that we had above. We can try to print that to see what that looks like. So you can see here we created a polygon object that has the shell of the border coordinate tuples, and then it also contains the whole coordinate tuples for the whole. So let's just try to run a cell with the frame to see what that looks like. You can see it has the same size as the world polygon we created above, but it also has a hole here that matches the hole that we defined above. So here the polygon is basically only the green area that is the frame here. Okay, I hope that was understandable. But then we can try to look into the attributes that we can use for the polygons. And then there will be a check your understanding after that. So some of the handy attributes that polygons has that we will be using for different analysis later on is, for example, the finding the polygon centroid. You see these are formatted. We can turn them into a F string. So here, if we were in curly brackets, if we use the world polygon that we created, world, and then centroid, like we did with the line strings, we could get the centroid, and the same we can do for the polygon area to calculate the size of the area. So world dot area, and also here for bounds, we can get the outer bounds of the polygon. I'll just fill out these, and we can look at the outputs after that and go through that. We can also get the exterior of the polygon and also the length of the polygon. All right, so if we run that cell with all the different attributes of our polygon, we can see we get the centroid of the point is it's a point at the at 0 for the x coordinate and 0 for the y coordinates, so situated in the center. We get an area calculation, and we also get the bounding box. So all the points at the outer ring of our polygon, or the points at the outermost points of the polygon. And we also get a exterior here, and here you see we get the linear ring object that has coordinate tuples for all the corners of our polygon, and then we also have a length attribute, so the length of that linear ring, basically the length around our polygon. Okay, that was a bit quick, but I will give you the opportunity now to check your understanding. These values that we get output now would not necessarily make that much sense in the Cartesian coordinate system, but when we start to work later on with other reference systems, then they might make more sense, like the length of a line that represents a road, for example, or something like that. So don't worry if it's a bit confusing for now. I am pretty sure it will make more sense when we start interacting in other coordinate systems as well. Okay, but now is a chance for you to check your understandings. I would like you to create 4 different objects, geometric objects. So try to construct these different objects, a pentagon, and there are some example coordinates there that can be used for that, and then also a triangle, a square, and then a circle. A circle might be a bit difficult, but if you have time, then you can look around on the internet and use the also the Shapely user manual and see if you get some hints from that. Okay, I see a few check marks, but I will I see even more now. Good. Okay. I will go through how or one way to create these different shapes using Shapely. So the first object that I wanted you to create was the pentagon. So as you can see there, there were also some example coordinates. And so basically the pentagon is a polygon with 5 corners. So we can create a polygon object and pass it a list of different points or coordinate tuples. So in interest of time, I'll just copy the coordinates here and paste them. And if we run this cell, you can see a pentagon was created, a polygon with 5 points. So that is the same way as we created polygons earlier. And then for the triangle, so that is a polygon with 3 points. So for that, we can create a polygon in the same way with the constructor and pass it three tuple points. So if we start with the first coordinate at 0.0 or 0.0, and then pass another tuple with 2 on the x-axis and 4 on the y, and then the last with 4 on the x-axis and 0 on the y, we would create this triangle. And so here, as we have mentioned earlier, the polygon constructor takes an ordered list. So here the order matters for where the lines between the points are created. That makes up the polygon. So yeah, we could change these in order to make a different right-angled polygon, for example, by changing the last coordinate tuple. And then you're asked to create a square like this, and that is also a polygon that we created. Let me just use the same as in the triangle here. Let me see, use the original triangle and then pass it last point, or yeah, this would not make a square, that would make a polygon because we created that point twice. But here, if we have the first on x0 and y0, then in order to create the square, the next one would then be also 0 on the x-axis and then 4 across on the y-axis, and then up and around, and that would make a square polygon. And then the last was a circle. That might have been a bit tricky because the shape doesn't have a circle object, but one way we could do that is by creating a point. So if we create a point and pass it the coordinate tuples of 0 and 0, if we just check that, then we see we get a point. But if by using an attribute that we will be using a lot later on, buffer, that will create a buffer around that point. So if we pass it a buffer of 1, then it would create a circle. So that might have been a bit tricky, but we will get into buffering and other types of attributes and analysis in the coming weeks as well. All right, then the next section in the lesson material here is about geometry collections. So that is about the multi version of the geometric objects that we have been gone through today. So multi-point, multi-line string, and multi-polygon. This is optional. I'll just run a few cells a bit quickly. We will be talking about these objects a lot later. So if you want to just get a little bit ahead of the game, you can go through this as well. We will be also reiterating those later, but they work in a similar manner as the line strings and the points and the polygons that we learned today. So, but we need to import those methods and objects from Shapely, and by here creating a multi-point with a list of multiple points, or with a list of multiple coordinate tuples. And we can do the same in with a multi-line string. Pass it a list of different lines. If we run this cell, we have created a multi-point and a multi-line string. And if we inspect those, we can see here we have one object that contains 3 points. And we have a multi-line object that contains, in this case, these are 2 lines, even though they can look like one line as well. And the same goes for multi-polygons, where we can, if we run this cell, we can see we get we create a polygon from just the half of the world, that the polygon that we used earlier. So one of the reasons why these multi versions of the geometric objects might be useful is, for instance, we will later be working on data sets that if you have in a GIS file, for example, you can have a bunch of rows with different objects, and then, for example, for the country of Finland, for example, the Åland archipelago would consist of multiple islands, and you could have those in one row of the GIS file, but as a multi-polygon object, for example. So you can, I won't go through the rest of this notebook. It's there for you to read if you want to, and have time for that. Now I recommend you to do it. It's handy, and it will be useful for later on. But I think not to drag out the first lesson too long, I will jump over to this week's exercise.